quick show of hands so I can frame the talk a little bit better. How many folks work in a venture that's dedicated to big data? Okay, I assume the rest of you are working in a company that is applying big data, but the purpose of the company is not big data in and of itself. Fair? Great. That's very much my perspective. So I'm the Chief Technologist at Dyn, and Dyn powers internet performance for 12% of the 500 largest websites on the planet. So everyone from Twitter to Netflix to LinkedIn and thousands in between, we power the global traffic management and global message management. And the reason I care so much about the Internet of Things is it's one of the next big shifts that we look to when we try to understand how is the Internet going to look tomorrow. What trends can we look at today that give us clues about how the Internet will look tomorrow? And it's intricately tied in with how we understand big data today. Most of what we think of as big data today, I call analysis of data exhaust. It basically means the databases and the telemetry data that we've collected from running our services day in and day out. We tried to find value hidden somewhere in those haystacks. We try to take piles and piles of data and understanding what's compelling about it. What can we offer to a user that would be a compelling offer for them to take next? But that's just the exhaust of running existing services and systems. And businesses, while they've found a lot of value in that, and the cartoon you had up in front, really, it kind of emphasized it, of the Google acquisition of the Nest, looking at the combination with Google AdWords, and how could I offer someone a fire extinguisher ad if I knew their house was on fire, right? And it's kind of your typical example from a marketing perspective of how big data can be applied. But when we look at the Internet of Things, my friend Brody here would say you're going to need a bigger boat when it comes to your understanding of big data. Because the value we've generated to date, just on the data exhaust, has been so compelling that businesses are now actively seeking out more data in the hope of finding value. This is a very big shift. Just running our services, just the databases, just the telemetry has been everything that we know of data to date. When we actively go try to find more data, we are going to have a very different set of problems in our hands.
Is it possible to turn the lights that are shining right on that screen down a little bit?
This is the darkest slide I got. Everything's uphill for me. Just like my voice. And so outside of like marketing offers, that's kind of what's enabled us to invest in Hadoop clusters, telemetry, different analytics tools to date. But that's not the real value. The real value is going to be in what we can do to deliver a superior user experience that will have people voting with their feet, voting with their wallets, right? Just being able to show someone an ad that's slightly better than the previous one, incremental improvement. But why would you switch banks? I would argue that if someone was going to offer you a 0.1% difference in your savings rate, not compelling to go through the hassle. But if someone could offer you a compelling mobile experience, where you can deposit your checks through a mobile app, your phone would tell you when you're nearest the ATM, and you can get cash before you head out for the evening. You can transfer balances from account to account without ever having to call up, without ever having to visit a branch. That's a compelling experience. And if we look at the tech industry, we see plenty of examples that are neighbors of compelling experiences. First one, of course, is Nest. $3 billion of enterprise value generated in a friggin' thermostat. No one thought this would have been possible. Reimagining what it means to order transportation, another $3 billion. Everyone being able to process a credit card in their pocket, $5 billion. These are examples of user experiences that challenged the status quo and had people voting with their feet, right? But when I talk about the data exhaust, it's the data exhausting off of these value props that I'm referring to. It's when people start putting more sensors into machines where we have to rethink big data. And the user experience is the #1 business reason for people to do that. And we don't just look inside the technology industry. We can look to American Express, who has done one of the best studies of customer service to understand how these trends have evolved over time. So in 2010, they did a study trying to understand what people would do if they had an expectation of superior customer service experience. And in 2010, they had 58% of folks saying they would pay a higher price. Optimal premium, about 9%. Kind of interesting, a little more than half of consumers. But look how the trends evolve over time. 2 years later, 66% would vote with their feet, and they would pay even more than they would before. This is what businesses are responding to. Your superior experience is now how you deliver long-time competitive advantage. And when folks were actually asked, hey, have you actually voted with your feet for a superior experience? That number went up too, right? So businesses are responding in kind. And when I see the Internet of Things and big data, we get so caught up in the terminology of what the technology actually is that we forget the real point. The real point of these things is to make the technology invisible so that we can deliver compelling value to someone. One of the biggest folks that is driving change in how we think of big data and the infrastructure that has to enable it is John Deere. In Asia Pacific, huge agricultural growth market. Lots of agricultural machinery, industrial machinery being sold into that market. All of this machinery has telemetry data that phones home everything from maintenance records to where fertilizer has been applied in a field to how effective one operator is over another operator in setting up that piece of equipment. But for all of the value of that telemetry data to work, you need internet connectivity. Well, there's a little problem with internet connectivity in the world today, in that we're running out of addresses for it to work. Right now, we have about 7 billion people on the planet. We have about 14 billion networked devices, things. These are typically the things that a human being is directly interacting with to consume some sort of content or some sort of application, right? It's a network between people and content. But that agriculture example I just showed is not about people. That's about a machine communicating with another machine, actively producing more data than it ever had to before in the hope of delivering some value to a customer so that that customer will buy more of that equipment. That problem is explosive. In the next 6 years, we expect 50 billion connected devices. When we talk about the Internet of Things, this explosion from 14 billion connected network devices to 50, that is the Internet of Things that we are talking about. Where we're not talking about humans interacting with content, we're talking about machines interacting with machines. And there's a little bit of problem when we look to the architecture of the Internet of how it's supposed to enable this. We only have 4 billion addresses. Now, how has the Internet been able to grow to date when we already have a couple multiples of that in terms of people connected on the planet? Well, any technologist here knows that you can stretch an architecture with duct tape and fixes and patches for about 2 or 3x, not 10x. You can't stretch architectures orders of magnitude. They have to be rethought. And decades ago, folks did rethink the addressing scheme of the Internet and came up with IPv6. Plenty more addresses. But they tried an adoption strategy of the sky is falling to get people to switch over from IPv4 to IPv6. They tried putting countdown timers for when the Internet would run out of IPv4 addresses, hoping that would compel people to switch. It did not. It did not. So what ended up happening is you have folks like John Deere and other agricultural vendors selling connected agriculture equipment into Asia Pacific. There's no V4 connectivity left in Asia Pacific. The only way you can get the value out of that equipment is to connect it to the V6 network. It's the only addressing scheme available there. Agriculture is now the #1 driver of IPv6 adoption. And that value of what you get from that connected machine is so compelling that it'll jump over leaps and bounds of the technology barriers that have been in the way. And so when we think of the value that we deliver to people, trying to scare them of the internet's going to run out of addresses, you should switch, doesn't actually compel people. You tell them that I can deliver the value of this connected agriculture equipment, and you can operate that more inexpensively on this V6 network, people actually vote with their feet, right? The opportunity is compelling, the fear is not. Run this forward a couple of years, and we're going to have an interesting phenomenon. The number of addresses available in V6 massively dwarfs what we can do in V4, to the point where there's enough value generated of V6 to V6 devices and enough machines communicating with machines. Keep in mind, we're going from 14 billion to 50 billion devices. Eventually, our V4 internet as we know it, that connects humans to content, will look like a rounding error on the V6 internet. Eventually, it will become more expensive to operate a V4 internet connection than it will a V6 internet connection. Because that's where our investment is going to go. Not because we fear losing our V4 internet, but because there's opportunity of connecting so many more devices enabled by a V6 internet, right? So that's the first phase of the Internet of Things rollout. Very much infrastructure, very much businesses addicted to the value they've been able to find in the data they already had, and now actively in search of more value. And that active search is what's driving the active pursuit and collection of more data. And those devices, sensors, telemetry devices, remote control platforms, those are the devices producing this additional data. Well, just connecting all the infrastructure and addressing them, well, that's part of the battle. Cloud has been a huge enabler for the second part. People being able to test value props without having to buy all the hardware up front. Test an application, test some data crunching, see what you get out of it. It wasn't really possible before at the cost levels that we see today. But the reason I come here is not to talk about how the internet's going to evolve. This is stuff that's happening now, but is actually just the foundation for what's relevant to the folks that are here. And that foundation is what we think of in terms of the analytics. If all of our efforts to date have just been on the data exhaust, what do we have to do to get ready for analysis of actively produced orders of magnitude additional data above and beyond what we have? What do we have to do to take it from we're going to offer a more compelling ad the next time this user comes to a property, which is kind of the highest level value prop most folks think of for big data today, into how can I make this service fundamentally more compelling to that user that they'd be willing to vote with their feet, right? Think of the data that we can get from cars. Think of the data that we can get from smartphones that aren't actively producing it now. Think of the data that we can get that is just lost as telemetry. These are the pieces we have yet to dive into, right? Now, when we enable the technology platforms to analyze this data, all right, that's one piece of it. The next piece that we run into is a huge barrier, is how we started off this whole meetup. And that piece is the people that actually understand how to insert value that wasn't there before into a product or service with or via the additional data provided. So you can basically think of this as 3 waves. The first wave has been running for the last 15 years, the infrastructure wave, the connectivity of devices, the low-cost computing capabilities of the cloud, the addressing scheme for V6 that is supported at network operators, not so much for human beings as users. That infrastructure phase is largely coming to a close. The reason we're interested in it at Dyn is because we do remote access and connectivity for over 5 million devices around the world. Not only do we power the big brands that I mentioned, our history and origins go all the way back to a service called dyndns.org. That was us. We were the ones doing remote access via dynamic DNS. There's now 5 million folks around the world doing that. The barriers that we ran into in being able to take that service to the next level were fundamentally because we were talking about the technology. The folks that actually made the thermostat a compelling $250 purchase weren't just giving you a connected thermostat. It was reimagining the experience of what it meant to interact with your home heating and cooling system. The experience of you never had to come home to a cold house in the winter or a hot house in the summer. The people that fought through that and how to make the technology invisible, that's our third phase and the next barrier that we face. Because we're still so addicted to talking about the technology. We're still so addicted to talking about how things connect under the hood, or what analysis cluster we're going to use, whether it's Hadoop or some other analysis package. We get so focused on that that we lose the point of the real value to the end user, which is making the technology fundamentally disappear. These folks are not being trained today in universities. These folks are not just going to stumble upon these skill sets. The charter is among all of us to be able to educate these folks in how to understand the technology, understand the infrastructure, understand the analysis, but fundamentally think, if you were in that user's shoes, what would be compelling to have you vote with your feet, vote with your wallet, take money out and put it in someone else's in exchange for some pain going away or some opportunity. First phase, infrastructure, largely wrapping up. Second phase, what we know of is big data, about to become small data once we're actively producing orders of magnitude more data to analyze. We're at the very early stages of that. But we have yet to really address this challenge of the talent that's ultimately going to be able to bring these products and services to life. How we address that today is going to enable what products and services we all enjoy and experience 10 years from now. Because we have just begun this journey. Just begun. And I've only been looking at it from that first phase, the infrastructure perspective. And we only have a couple small home runs from an analysis perspective, and even fewer home runs from a full value perspective. These are the foundations that we have to lay today, and we can't lose sight of that forest for the trees. So that's the last of my canned kind of spiel to set up the talk. In summary, and before we make this interactive, the conversion of data exhaust to the active production of new data in the hope of finding value is the next big transition from a technology enablement perspective. And our thinking is going to shift from how can we just have a marketing value delivered to get users to click additional ads into how can we rethink an existing value prop or service or capability and do things that were fundamentally not possible before. Haven't really tackled too many of those yet. And then we see 3 phases for that evolution, right? So what are we doing at Dyn to get ready for this? And this is what I'd love the interactive session to be, so that I could give my voice a tiny little bit of a break. Okay? So what we're doing at Dyn is we pay attention. We've gotten some of that marketing benefit, that marketing value. Very, very simple things that we've done. We run an annual self-service line of our business where you pay $3 a year and you get a subscription to that remote access service for that year. Pretty simple, right? We were actually one of the first freemium models on the internet, getting started back in 1998 with remote access. When we actually looked under the hood and figured out what purchase patterns were going on, we noticed that we were only retaining about 65% of our clients year over year. That's really low. They all seem happy. Why is it so low? When we look at the purchase behavior, we found out that we were having a service that they might have bought in 2010 on a Thursday afternoon being calculated the following year for renewal on a different day of the week. And whereas someone might be buying something on a Monday afternoon, Tuesday afternoon, Wednesday afternoon, if we then go, when that service is up for expiry the next year, and it happens to fall on a Saturday, and we send a notice saying, hey, take action now, renew this service, or your service is going to go away. Basically, the renew now or it expires notice, the most urgent one, the one we actually all pay attention to. You know, the ones that say expiring in 30 days, I don't feel that, right? But the one that says it's going to expire tomorrow, everyone pays attention to. But we were sending that and landing in their inboxes over the weekend. Now, this is a service that we operated. We were beholden to no one in terms of when it expired. What we did is we took anything that was going to expire on Saturday, Sunday, or Monday. Thus, the most urgent email, the Renew Now email, was getting sent out on a Friday, Saturday, or Sunday, the day before. We shifted all of those to expire on Tuesdays so that the You Must Renew Now emails all went out on Monday. Our retention rate went up to 80%. There's a lot of value left in those marketing tactics, but we didn't fundamentally reimagine the product. We didn't make it fundamentally better for the user. We didn't reimagine the experience. But that was the initial start of convincing the business that understanding, being able to process the data that we already had to find that value, was compelling to invest some more so that we could understand more of what was going on. And now we're at the stages of the investments we made there in our analytical capabilities, which are a combination of machines, software, but most importantly, talent. The investments we were able to make in the talent there have now been able to rethink how we do global traffic management. Perfect use case. User is typing in twitter.com from Europe. How can we tell where they are in Europe to be able to send them to Twitter's closest data center automatically? How can we tell the health of Twitter's infrastructure around the world so we never send anyone to a downed server at Twitter? And then what becomes more compelling over time is not just, hey, the users in France, send them here, or the users in Portugal, send them there. It's actually, wherever the user is in the world, how can you connect them with the best possible experience for them to enjoy that application, right? But now we shifted from looking at just geopolitical query log data, the data exhaust, into how can we actively produce more data to understand where users are in the world, how the internet is connected together, and how the changes over time. A perfect example is when an undersea cable gets cut. Happens all the time. All the time. Huge impact to the routing table of the internet. But if we can understand how those connections will behave proactively before those connections are lost, we can better model how users would get routed around that outage and make sure that we never deliver anyone a poor experience in Twitter.com, right? So it's the perfect example of there was some marketing value to be had. We generated some returns. The business found it viable. We invested some more. We're now fundamentally rethinking the product and how it works, actively seeking more data, not just is the IP up or down and where do we think the user's coming from, but active BGP routing data pulled into our algorithms, active multi-endpoint testing to understand how this application is loaded, not just from one perspective, but from 20 around the world, right? We've been able to steamroll this to get the investment we need to ultimately deliver a better experience to our customers, just so happens to be website owners and operators, but you can see the journey that we've applied. And it's not fast. It's taken us years, about 4 years in of that effort so far. Most of that blocked by the talent. The people that can actually understand it, not just to find the value in the data that we have, but to pick what data we need to go collect next. And then the ultimate piece that we're bottlenecked on, the people that can understand how can I make this experience better now that I can understand what is happening out in the world more than I could before, right? So there's an example of Dyn's journey, right? And now I'd love to hear perspectives of journeys that are here. What are some examples where folks have been able to find marketing value? And ultimately, what are some examples where folks have been able to rethink the experience that they've been able to provide by actively seeking more data?
You see that 60 Minutes piece on the trading and the milliseconds response and what they came up with, their wire in a box. That was ingenious, but I mean, to understand the implications of where that intercept was happening and the millisecond delays for people to actually go buy out the $25 Microsoft stack and offer it back to you at $35, they only give you 60% of what you wanted. That was an enlightening, interesting, article. On 60 Minutes. I assume some of this, the things you're talking about, the routing, et cetera, could actually embrace a number of trading, actually not trading, but actually, transactional type things everywhere, I would think. I mean, that's got to be, if you take that same scenario and apply it to different areas, isn't some of that going on? Or what, are you looking at that at all?
Well, I mean, that's a perfect example of we can only pay attention to so many things, and we end up being kind of myopically focused in the history of how we got here, right? History is very compelling in terms of focusing your thoughts on the future. It's hard to escape that. So every piece of technology we've developed, I have to admit it, we've only thought of it from an internet performance angle, right? How can I deliver a better experience to that user? We haven't really thought of it from that, right? So that's an example of, as an executive in the company, how can I remove some of the blinders potentially to think of what we have built today, how is it applicable to customers that are different than the customers that we have just today?
And that was just optimal routing, or basically taking optimal routing and making it suboptimal for some, some paths. Huh? Did you see the 60 Minutes presentation regarding the trading happening out of Manhattan? Their first line was they had multiple paths back to the trading exchange. Well, they found out, and then people began to scratch their heads, why in the world were all these trades that they're offering, they'd only get 60% of the trade at that value, and they'd be offered within milliseconds another trade to fulfill their order, they'd have to pay a higher price. So they went in at 25, say 100 shares, they'd get maybe 60 shares at the 25, and then right back, the next thing was, the other 40 shares you wanted were offered at $27 or $30 a share. Come to find out, it had to do with the way the paths were being routed and how it got out across the internet to make their trades, and they were being intercepted in milliseconds. Those trades were being gobbled up because somebody knew, hey, somebody wants to go buy 100 shares, we'll buy them at the 25, we'll sell them back at 35, right? So that's the way it happened, and that was strictly the magnitude of and the volume of transactions and the complications of all the routes, which is kind of in their space. I just thought it was a pretty interesting scenario. That had to do, and it had to be applicable to other things besides just the stock exchange. And the volume, the amount of data, and the complexity. Did anybody see that? Yeah.
Well, it really changed the market. Well, it changed the market. Someone's getting ahead of everybody else, so I'm not sure that we're not getting. But somebody's always getting ahead of a millisecond. And change the market, pricing, market products, technologies, and
I'm thinking about when we start talking about international things and transactions happening that other players are involved in and have knowledge of because of the technology lift, because they're able to, with low latency, analyze the data, volumes of data, predictably figure out where they should be, buy things and resell them is a simple matter, but not just stocks, other things that might be applicable, including energy, number one. Okay.
And if we think of that marketing value prop, my voice is back. If we think of that marketing value prop we talked about in the beginning of how can I show a more relevant fire extinguisher ad if I know the user's house is on fire, right? And then we took a step forward for humanity's benefit and thought about how can I deliver a more compelling service or value or just make this fundamentally work better with the additional data. I'd almost argue the arbitrage that we see sometimes in financial networks is a step in the other direction, which is purely taking advantage of the physical parameters and differences between how information moves around networks to beat the next guy, right, or the next girl. And there's a bit of a shame in it in terms of our analytics community, because when stories like that come out, it casts such a negative light that counters so much of the positive light that we've been able to generate in thinking of new value and new services and new capabilities that were not possible before, into how can you do something in a millisecond before someone else and make a couple bucks.
I thought the solution was pretty interesting. They took fiber and they wound it up in a box to make the transmission time equal going out.
Yep, that's what they do. The most expensive co-location in the world is connecting to a Wall Street exchange, right? Because it's the lowest number of milliseconds away from other transactions. And what they do is they physically provide, no matter how close you are to the central cabinet, you get the same amount of cable. And it just winds up. There's no other way to do it. Yes?
Actually, I had two things. First of all, I have a friend who worked at Climate Corporation, which I suspect you're familiar with from your example, and that's a great story. I can talk a little bit about that. But first, I was wondering, Google, of course, had their own thermostat, and all the brains of Google and analytics and user interface that went into that, and it just cratered compared to Nest, which was this little startup that had some smart people, but nothing like the resources of Google or the experience and so forth. So how do you explain that Nest did well and Google's tanked?
Goes back to this.
Sorry. And how was your user experience better, and how did they figure it out? I mean,
this technology became invisible, right? To do a remote access thermostat, I've been doing that for a decade, right? I had my dynamic DNS account set up to my home server with port forwarding into a connected thermostat so that from work I could set the temperature, right? But to rethink the experience, the Nest has been able to take away, I'm setting whether or not I'm there in the scheduling side, right? It's mostly the scheduling side of when the thermostat is on or off. Nest has been able to rethink, and that's what it's been able to do today. But to give you an example of what is a way to think even further along that vein to challenge the experience, how could someone out-Nest Nest, right? Why do we even set things in terms of temperatures?
Comfort and money.
But why quantify it in temperature? Isn't that just the technology getting in the way? Right? Isn't it whatever I'm warm or hot, why do I need to know what the exact temperature is? Why is it 72 degrees or 74 degrees or 78 degrees? Right? There's another example of an interface barrier that's artificial between human comfort and the technology that decides when to turn on and off a heating appliance or a cooling appliance, right? The people that think that way, that can see what is the barrier, what is the interface that I can break down between a human and what they're actually trying to accomplish, which is comfort, those are the folks that are the hardest to find, the hardest to train. So to answer your question,
Google was skunked because they didn't have that skill, despite all their human efforts and the way they recruit and everything else.
Well, I would say that they started technology first, so bottom up, as opposed to experience down.
Okay.
And I think they learned a lesson. And I don't think there's anything wrong with them applying Nest to then fix that lesson. Yeah. It's a perfect example, right? If you can't build a competency internally in your own company, go buy it, right? You're deploying capital either way. You're either going to deploy capital that's going to take a long time to get trained and acquired and get up to speed, or you can accelerate your time to getting that all productive by buying them. So people might say that the internal Google effort was a failure because they had to acquire Nest. I look at it the other way around. They were able to tackle how some of the technology would work, but they didn't think or educate the consumer first. Someone else did. Add that on to the technology underpinnings that they have, you now have the whole suite, right? And I think the people that think that way are our biggest barrier in the end to being able to get the value out of big data, what's actually possible with it, and to collect all of this data, make sure we understand it, and then be able to apply it to that value. Like we get so caught up in the technology and such, it's really the people. That's a real problem.
So people understand temperature, do they understand degree days? That's where it's coming from.
Yeah.
Degree days is like the integrations and stuff, right? And it's math and complex, not that complex, but I mean, most people understand hot and cold temperature, right?
But they don't think I can really go for 72 degrees right now. 71 is a little more. You don't really think that way.
Yeah.
It's the interface into the machinery that's forcing us to think that way.
How to fake the furnace so it gives you the temperature you want, even though it's not really 71, right?
Right. And so that's when we talk about applying the value, breaking down those barriers of how a human is having to force their mental model into artificial frames in order to get their desired result. The more of those barriers you break down, that is by definition a smoother, more intuitive user experience.
So we're talking about climate. So you can talk about Climate Corp. That's actually a very interesting story.
By all means, I'm saving my voice.
You want me to do it? Okay.
Yeah, so sure they can hear you.
Okay, I have this friend who worked for Climate Corp, which was just acquired for over $1 billion last year by Monsanto, the huge agricultural company. And what Climate Corp does, again, going back to that picture of what John Deere does with sensors in their combines and their tractors and so forth, is they measure the microclimates. They have satellite imagery that they use, but now they've got a lot of customers in the farming community that have sensors in their fields. And so not only can they look at the microclimate, but they can look at the yields of specific crops and tell the farmer how many of what type of plant to plant when and where, exactly what day should they plant something, and how many inches or whatever should each corn plant be planted away, in a way that increases the yields of the plant, of the farms dramatically, at least 10%, maybe even 20%. So they can look at a field and say, they should be growing corn there, it's too dry for corn, they should be growing wheat, or something like that. They can make a lot more money with wheat. Or another aspect is that they can tell a farmer before he drives his $500,000 combine several miles down the road, burning out $50 of fuel just to get there, that field's wet right now, you really can't go there. So hold that off for another day. So there's a huge amount of value in it that they've managed to harvest. And it's very non-trivial because there's a combination of forecasting, analytics, and reaching out from, you've got these essentially nerd geek types who are all into predictive analytics, is probably more represented here, and then people who grew up on farms, which just to communicate to those people and have the user interface work out is just incredible. So that's the nutshell of the story. It's just, but coming up with these new applications and finding those new use cases, it looks easy after the fact, but trying to anticipate them before. I mean, I would have never thought that Google would have just failed. I just thought several years ago, oh, Google's going to take over this market, game over. But figuring out all these things is, going forward, what's going to be the next application that you can take advantage of without getting into some huge market that a small startup can't really tackle without a huge amount of funding. What approaches should you take to find those use cases, analyze the customers, understand human behavior better, and combine all those things? It's not easy, but it's very interesting, as you know.
Agreed. So I in here for interesting use cases.
Yeah, so I was surprised that you led in with IPv6 networking, in that it seems to me with the Internet of Things we have different requirements than we have. Right now we have very bursty requirements, latency is very important, the distances make it be different. So I was expecting you to lead towards mesh networks and self-organizing networks.
I would love to, with your permission. And when I usually go into the deep networking stuff, then I see some eyes glaze over, but he brought it up, not me, so if you don't like this, all right. The addressing scheme is actually a very small part of the problem, right? It's just a more tractable one for people to understand, to just really appreciate. We have been able to take the internet from 4 billion addresses that support 7 billion people because we've been able to duct tape and patch it, right? Things like network address translation have given us the ability to map networks, but it's also fundamentally broken the way that machines can communicate with one another, the way they were originally intended to communicate with one another. And one of the things that we notice as the internet continues to expand, most of the growth of the internet is not near where the backbone of the internet is, right? Most of the growth of the internet in terms of new net users are in Asia Pacific, Africa, and South America. That is where most new people connected to the internet per day are based.
Why is that?
Because that is the unconnected population.
The largest population?
We have just reached diminishing returns of new people to connect to the internet in North America and Europe. Right? And folks, where it was not economically viable before to lay cables, are now experiencing the internet for the first time using a mobile device. Because it is far more efficient to connect a large geographic area with mobile than it is with wired connections. And the economics behind those devices are fundamentally different from the PCs and desktops that we all started our internet experience with. You're talking a user connecting to the internet at a price point of $50 US in terms of the hardware requirements instead of 500 or 5,000 like it was before. Right? So now you have this mobile first piece, and those users are geographically far away from where the backbone of the internet is, predominantly Europe, crossing the oceans, and North America. The enemy for performance of the internet is the speed of light, the barrier upon which we cannot cross. If you think of the amount of time it takes information to go from a user on the East Coast of the United States to a server that's on the West Coast of the United States and come back, you might not think that would take very long. Theoretically, it's about 50 milliseconds if you just did the speed of light math. Practically, it's more like 90 milliseconds. And that's just due to the inefficiencies of the equipment, repeaters, so on and so forth. Where this plays a factor is all of the stuff that we've designed for our networking equipment to date has been around humans and content. And when we think of loading a web page like CNN.com, what we don't know of is going on behind the scenes is hundreds and hundreds, sometimes thousands, of what's called round trips. Every piece of data that is going to go from the user in terms of a request of I want this content to that server, that request needs to get acknowledged. That's TCP/IP. That's the transmission control. Every piece, every bit that has to move back and forth essentially has an acknowledgement part. This basically means that the longer the distance between user and content, the lower the performance. The number one negative impact on your experience as a human on the internet is not your bandwidth connection, how wide your pipe is to the internet. It's actually how physically close you are to where that content is in the world. The latency, that round trip time, that 100 milliseconds coast to coast has far more of an impact on your perceived experience online than your bandwidth connection to the internet. This becomes a problem when we start having devices communicate with one another. Because when we as application developers and programmers think of accessing a piece of data, we typically grew up in a world where we had local access to that data, where we were on a local area network. We had latencies measured in single-digit milliseconds. The connections were reliable. When we take those upbringings and apply them now to find this new value with these new machine-to-machine networks, we get very, very different behavior out in the wild. The distances that the information has to travel is now much longer. That round trip time has a huge effect in terms of latency, mostly around when we need to replicate data around the world. We get into big, big problems where the data in one spot is up to date, but it hasn't yet propagated to the others. It's much harder to design applications for these eventual consistency capabilities than it is to just have everything stored in one spot. Right? When we tackled this problem for the human and content internet, we did things like deploy content delivery networks. Great companies like Akamai and Limelight and a whole bunch of others sprouted up to be able to deploy web servers all around the world that would hold cached content or static objects. They would be physically close to where users were in the world to keep those latencies as small as possible. Right? Fantastic for video. Fantastic for images. Well, what about the telemetry data that we're talking about? What about things that are truly dynamic? CDNs don't help. We have to break applications up into pieces and push them around the world so that the application, not just the content, the application, the code, and the data is physically close to wherever those users or those devices are in the world to get those latencies down and make them manageable, right? So that's just the challenges we face in the device to application network that gets built. How we get data in, right? We have latency concerns. We have pushing the internet closer to where the growth is as opposed to where the backbone is. And we have, how do we horizontally scale that architecture so that rather than having one giant application in, say, Boston, you have just the infrastructure you need in the East Coast, just the infrastructure you need in Europe, just the infrastructure you need in Asia Pacific, just the infrastructure you need on the West Coast, so on and so forth, right? So those are the internet side effects that we have. Yes?
What are they? Because I think everybody's addressing the large populations, but I always hear this concern about, well, how do I get this? And it has to do with education primarily that I've in my dealings. The internet delivered with the bandwidth to XYZ farm community out in Kansas that doesn't have the luxury of a high bandwidth internet sitting around Boston like we have.
But this is why we see companies like Google and Facebook acquiring interesting technologies that can cost efficiently deploy internet connectivity to remote areas, right? It's why you see them invest in balloons, drones, and other sort of aerial repeaters that can extend those wireless networks very efficiently, right? And so if you're Google or you're Facebook, that user experience, that's your biggest strategic risk. Someone delivers a better, more compelling experience than you. If the network ends up being the barrier to delivering a great experience, business strategy 101 is whatever is your biggest strategic risk, own it. Don't depend on someone else. Don't let someone else rule your destiny. How can you own that to make sure it gets done with your parameters as a first-class citizen, right? That's why you see folks investing in those technologies. But the next barrier that we face is not just that device to cloud, if you will, connectivity. When a user brings home a new Internet of Thing device, a new connected device that they want to have as part of their life, the only real way that you can reliably make that work today is with Wi-Fi. But there are so many better protocols and technologies, not only for the physical layer, if you will, of actual transmission of bits and bytes, but for the protocols on top that consume less power, are cleaner from a network utilization perspective, and are more scalable. But the experience isn't the same. One of the gentleman that we hired as our VP of engineering, he was the director of high-speed internet at Comcast, and he sits on some of the protocol committees for IETF. And he talks through all of the wonderful protocol that's developed, the development that's happening between Zigbee and low-power Bluetooth and different sorts of ways to enable auto configuration for V6 connectivity that would sit on top of those wireless technologies. The challenge is, all of the folks solving the great technical problems are not talking to the folks that are imagining the really great user experiences. And we're going to have tons of standards for how these devices should work, but it's not going to matter when the market's been educated that you can deliver this great user experience and you can serve it at a certain price point once you start making enough Wi-Fi chips. And we actually have a bigger technical problem that's a mess that we have to clean up later, because now all this stuff's out in the wild, right? That's what we have now, basically, with the explosion of network address translated devices, and trying to think of, my goodness, how do we map this over to V6? Well, it's actually the growth into new markets that will drive that, and eventually the V4 internet that we've kind of duct taped to where it is today is just going to look like a rounding error on V6. And eventually, when just like, it won't be the fear of Wi-Fi not working, or Wi-Fi over-congestion, or Wi-Fi signal interference that'll actually have folks convert their products to use other technologies. What will actually make those other technologies come to life is what value can be delivered inherent because of that technology either consumes less power, right? Or can operate further away. That's what will have folks switch how they actually deploy these technologies. Right now, it's largely Wi-Fi. We have pretty good movement of Bluetooth low energy, but mesh networking isn't really taking on because it's the challenges folks face in making that work reliably, a consumer making that work reliably, that the repeaters are all within the right distance, they don't interfere with one another. It only takes one frustrating experience for someone to tell their neighbor, yeah, I bought it, it's $500, but I couldn't get it to work, right? And that experience has to be right. That's one of the biggest barriers. Yes?
Yeah, you know, it's awesome. It does that really well. A lot of people don't do it well. It basically connects the what can you do, what are the limitations of technology, where that can go, what kind of time is, what really makes for a better user experience.
So it's too early for me to tell like which specific companies. But what I can tell you is, so I'm a mentor at the Harvard Innovation Lab and at Techstars Boston. And about a third of the folks that I talk to in either of those programs are now thinking of Internet of Things related problems, right? Where they're thinking of not just how you can tackle this one technical sliver of the stack, right? But how you can take the right amount of hardware with the right amount of protocol development, with the right of back-end application that would be in the cloud, and the right transmission between them, and the right analytical capabilities on top of that data, that whole end-to-end stack, and offering that as the technical solution to someone who thinks of a compelling user experience. Here's the toolkit upon which you can bring your user experience to life. Right? There's a lot of great folks that are starting to think of that. Right? In the same way that we had Amazon EC2 educate the market of what it meant to have API controllable infrastructure that you can rent by the hour. Right? They weren't the first ones to do it, but they were the ones that educated the market that this is now feasible. Right? One of these companies will educate the market of great experienced designers of this is what's now feasible at this price point and on the stack that makes it possible.
I'd like to assert that it never happened, that the technology stack can't all be leading edge, that the leading edge is built on a foundation of rock solid, mature technology. If it weren't, it wouldn't be usable. So we're always going to have city planning, we're going to have our historic buildings that we can't tear down, and we're going to have our new high-rises which are heat efficient and we would hold modern. It's always going to be like that. And the trick is going to be to find where the sliver of value is, that a new technology comes along which obviates or creates some opportunity which allows somebody to go in and disrupt. And it's always going to be a leapfrogging. It will never be a nice even growth.
Yes, it will never be a nice even growth. But in the same way that we think of historic buildings as now a very niche category of the global categories of housing and architecture and everything, same sort of thing, right? There'll either be some value props that are not compelling enough to reinvent and will just be supported. There's still plenty of COBOL out in the wild, right? Why rewrite it? No compelling value. Efficiency and scare tactics are often not as valuable as new opportunities that become possible, right? But I don't think that'll really get in the way of folks that want to reimagine how things work. But we will always be supporting those. And to your question, the best example I've ever been able to point to has been Steve Jobs. Right? But the awareness that he's generated in terms of what's possible, I think has now inspired not just one generation, but 3 generations of folks tackling these problems. Right? Of what is the, it's kind of like when Google launched the Nexus phone, their idea wasn't to actually sell phones. Their idea was to set the bar of the experience here, so the whole ecosystem had to either meet it or exceed it, otherwise don't even bother coming to the table. Right? When I advise the companies that are thinking of these Internet of Things platforms, they're just thinking, hey, if we build this great platform, some experienced designers can come and build a great experience with us. But they're not, you have no credibility. No one's going to take a risk on you. The only way they're going to take a risk on you is one of 2 things. Either you know them personally, and you're allowing your personal reputation carry into your startup's reputation. Okay, maybe they will. You know them? Or you don't? Okay, well then, it's going to be path 2, which is what application can you think of to set the bar of what experience can be delivered with your technology platform? First, make your startup about that. Make that successful. Prove that your technology stack actually enables a superior experience. And probably the current iteration does not, right? It's just the very act of developing a superior experience is going to force you to enable that stack to actually do what you think it can do. Once you've done that, stop being in the application business and sell it to the platform. But that process of building a compelling experience yourself is a mandatory step in that direction. And that's what forces people to think that it's not just about protocols. It's not just about what should be their variation. It's not just about how data moves around the network. It's actually how is this technology making experience and what's possible for it and possible. Yeah, don't get me wrong, that's definitely the exception in terms of how outlying it certainly is. But the process that we described is not fundamentally hard to explain, right? Whatever someone is doing now to receive some value from something, think of what artificial frames or barriers are in the process of receiving that value. And think of ways to take those away. That's really it, right?
I would say that Steve Jobs would be certainly an exception, but you'll get these solutions, these ideas from groups of people. You know, the brain sharing, right? It's around the interactive thought. It doesn't have to be left brain, right brain. It can be left brain. You can be right brain. You can be somewhere between. And that dialogue and that thinking, you have the space and the group to do it. That can achieve, something that, Steve Jobs will get to myself, but very few people are.
Well, we talk to each other and we kind of get very good perspective.
Right.
Who else has interesting use cases?
What about government interaction and regulations as a barrier as opposed to an enabler?
Great question, one I don't have expertise in.
I don't
So I'll
either.
turn that back to the
I
audience.
just
What about
the trigger
government
was
regulation?
Comment back there.
How does that enable or hinder these activities? No one else has expertise either. All right, we're all going to build great things. The government's going to come in and shut down later.
Well, look at the classic of CDMA versus, the various other technologies that are prevalent. You go to Europe and Asia, the adoption and the things that are going on out there are like at an accelerated pace above what's happening in the U.S. And I think part of that is the way we are regulating and haven't deregulated, bandwidth. People buying bandwidth, for example, and the way bandwidth is, boxed and used as opposed to not. And I think that has a lot to do with, you know, the ability to move at a different pace because of some conformities of regulation that you get slapped. You can't go beyond because it is a significant barrier, one that is like a giant wall as opposed to one that you can leap over. So I think a lot of that has to do with things we've done here in the U.S. that are maybe we should be learning from other parts of the world.
Agreed.
Regulations are, people handle things, right? So there's a cost to regulation, but there's a benefit.
Yep.
A lot of it. And maybe as an example, if you could say pharmaceuticals are regulated, right? So there's a price to regulation. All sorts of drugs that take a decade or more to get to market because we're trying to eliminate false positives on drug testing, right? You want to have regulation so you don't let loose catastrophic bad things that look good for a year and then you're killing them, right? So yeah, there's a line of regulation.
There's a nice balance that has to occur, but I'm not too sure that, you know, as you take in once, I think there were some people that actually would have a good argument, you know, against that for, you know, certain drugs and whatnot. Primarily the ones that are suffering from, you know, but I agree with you to a point, but I think this bandwidth piece and is out of control. That should not be our government's business to deal with at the level it is.
I mean, wireless bandwidth. I mean, you can't have people polluting wireless bandwidth with A, B, C, and D transmissions. It's got to be regulated. And that's if anything, it has to be regulated for it to work, doesn't it?
Yes. In a wide basis, that's what I'm saying. It's a fine line. I'm not arguing with the other. I'm just trying to get a conversation going to bring out some of the issues. I agree with you. I think, you know, you do need to, but I was trying to, take a devil's advocate to figure out.
You know, I mean, it could be that there's other factors. I mean, Europe mobile took off a lot more and a lot earlier than the U.S. Broadband connections to homes cost about double here. And South Korea has way higher broadband penetration and higher bandwidth quality. There's a whole bunch of things, but, you know, there's a lot of factors.
Well, do you think that the regulations stifle innovation and the ability to actually, from a cost standpoint, to move into a specific space?
I don't know. What do you think?
No, I do. I think that there's some strong barriers there. The cost, the ability to innovate, but yet actually distribute is there.
Cool, awesome. I think that wraps up our program. Yes, thank you so much, everyone. Thank you, Cory. Amazing discussion.